Section 5.5, Indefinite integrals and the substitution method. So in this section, we're going to solve the problem of finding indefinite integrals. So that means you need to find the integration of any function f of x. And sometime, problem they look very complicated, but by using the substitution method, we can change the problem into a simple looking type of problem. For example, here the substitution rules. Let's say you have a function and then it's a composition of two different functions and there is a derivative of inner function. Then you can always replace that inner function by u and change the problem into like this. Okay, and that idea of substitution helps us to solve the integration problem. So what do? First of all, find out a right function to substitute for, and then find the derivative of that function, and then all the variable x, change that into the variable of new substitution, like here in this case it's u, and then after that find the integration. Some of the standard integration for trigonometric functions are here, like integration of tangent of x is ln absolute value of secant of x, and then all of this you have to know this integration of trigonometric function as well. Let's look at some examples. For example, here, to find out the integration of this problem, first of all try to substitute for the function you have given, but make sure that whenever you do the substitution, the derivative of that substitution should be available here. In this case, I'm going to substitute this inner function here by u. So let's say u equal 4s minus 9. Now I need to find the derivative of u, which is du equal derivative of on the right side, which is derivative of s with respect to s is 1, so that would be 4. So we are trying to find the derivative with respect to s both sides. But now instead of du over ds, we can also write it down as a du equal 4 times ds. So we go back here in this problem and we're going to replace this value of u here. By doing that, you will be able to see 1 over u to the power half. The square root means power half, and this ds can be replaced by this value. If you solve this, ds is equal to du over 4. So we have to change that ds in terms of du. So that is du over 4. Now I can bring this 4 outside, so that will be 1 over 4 u to the power half. I'm just bringing this u to the top by changing the sign of this exponent du. So finding the integration of this is equivalent to finding the integration of this. Now for finding the integration of u to the power negative half, we can use the power rule for the integration, which is negative half plus 1 over negative half plus 1. Since this is indefinite integration, so you need plus c constant. Now just do the simplification here. 1 over 4, this is u to the power half, and then again if you add negative half and then 1, that will be 1 half. So you need to simplify that. This 1 half goes to 2 over 4. This 2 goes to up, if you flip it, and then this is u to the power half plus c. Eventually this is 1 half. We need to plug the value of u back from here. So u is actually 4s minus 9, and there is a power half plus c. So that will be our final answer. So we use the substitution to change the problem from complicated looking problem to simple looking problem, where we can use the formula of integration directly, but eventually we need to find our answer in terms of the original variable. In this case it's a s. Look at here, this is a new problem. Here there are two functions, as you can see, tangent and secant. So you need to substitute for one of the function, but make sure that when you do the substitution, derivative of that function should be available here. In this case, we can substitute for tangent. So let's say u equal tan of x. By doing that, what happens is we can say du, if you find the derivative of tangent of x with respect to x, it will be secant square of x. So that means the du can be replaced by or secant square x dx, meaning the secant square x dx, as you can see that is available here. I can replace this by du. So after that I can change this problem. Tangent is u, so I can write it down as a u to the power 6, and secant square x dx can be replaced by du from here. So now finding the integration of this problem is equivalent to the finding the integration of u to the power 6 with respect to u. So we can use the power rule of integration, which is 6 plus 1 over 6 plus 1, and then because it's an indefinite integral, so we need plus c. So this is u to the power 7 over 7 plus c. But finally we need answer in terms of x, so we're going to plug the value of u from here, which is 10 to the power 7 over 7 plus c, and that is our final answer. One more example. So make sure that whenever you do the substitution, that substitution should change this problem into simple looking problem. So in this case, whenever you have exponential function and trigonometric function, do the substitution for the exponent here. So if you substitute u equal negative cosine x, that will help us finding the derivative, which is the derivative of cosine is negative sine, and this negative and that negative becomes positive sine x. So that means du can be, this sine x dx can be replaced by du. So you can see that this sine x and dx is already available here. So this problem now becomes e to the power u du. So this is a simple integration problem. The integration of exponential function e to the power u with respect to u is actually e to the power u itself plus c. Plus c means it's because of indefinite integral. So e to the power u, we need to replace the value of u using this value, which is negative cosine of x plus c. So that is our final answer. So this is initial value problem, meaning after finding the integration, the indefinite integration, it gives you constant, but because of this initial condition, we can use that initial condition to solve for that constant. So for finding the s, if you just integrate, s is integration of ds over dt with respect to t. Okay, that is the relation. So ds over dt is given here, which is 28t times 7t square minus 5 cube. So we need to find out the integration of this complicated looking problem, but we can change this problem into simple looking by using the substitution for appropriate function. In this case, we need to substitute for this function, which is inside the parenthesis. So let's say u equal that 7t square minus 5, and don't forget that there is a dt. And now if you find the derivative with respect to t both sides, it will be 7 times 2 is 14t. Okay, so I can just replace this 14t dt by du. But here, if you look at here, you can see 28t dt. So instead of 28, I can write it down 2 times 14. So 14t dt can be replaced by du. So what I'm going to do is, I'm going to write it down this as a 2 times 14t dt can be replaced by du, and this thing can be replaced by u to the power 3 du. So look at here, du means 14t dt times 2 is 28. Okay, so now this is very simple problem because I can bring this 2 outside and I can find out the integration of u cube. That would be u to the power 3 plus 1 over 3 plus 1 by using the power rule of integration. So that is 2 over 4, which is 1 over 2, u to the power 4. But remember, u is 7t square minus 5, so this is 7t square minus 5 power 4 plus constant. So that is the value of s of t. That's s. That is the value of the function. But because we have given the value of the function at 1, so we need to find out the value of the constant. That's called initial value problem. Finally, we don't want our answer in terms of c. So what do we do? Just replace t by 1 and solve for c. By doing that, s of 1 which is actually 14 that's given here, is equal to, if you replace t here on the right side, that will be half times 7 times t square, which is 1 square, minus 5 to the power 4 plus c. Okay, okay, so 7 minus 5 is 2, so 14 equal half times 2 to the power 4 is 16 plus c. So 2 times 8 is 16. So if you solve for c by subtracting 8 from both sides, so you get c equals 6. So eventually, what is the answer? The answer would be, I'm going to go back here. I'm going to use this thing. The answer, S of t, is everything, copy everything, and just plug the value of c, which is 6. Half 7 t square minus 5 to the power 4 plus 6. So that is our answer. So remember, whenever you try to solve initial value problem, you need to find out the value of this constant. You cannot write down your answer in terms of c. You need to find out the value of constant by using that condition. Okay.